Right, here we go. Hello. How you all doing? Suppose that we're live. Then we'll do a brief recap. Okay. So, I guess to do a brief recap. So last stream was we've been doing the let's go to scripts. Go back. So we've been doing the PBR, the physically based rendering. So we've got these spheres here. These are some sort of metallic spheres, and we've obviously got a sun and things like this. Moving around. Just fix it a bit. But yeah, what you find out is that what we found out is that the performance for this to get PBR working has taken a bit of a tank because we've had to generate an irradiance map, which takes some time, and a reflection map for the sky map, basically. These two images here. So this is like for the specular reflections. It's just a bit of a blurry sky basically, and it takes time to generate these, and they're being generated every single frame that the sky changes. Well, every single frame that the sky, for the sky basically, and it's very computationally heavy. So what we're going to do today is basically improve the performance of those things. So what we can be, where's the other one? There's the irradiance image. Here we go. This is for the diffuse. Yeah. So generating these things takes time, and right now my frames per second is about it's about 30, I think, because it's about 32 ms. So it's not very good. Hey Rohan, how you doing? So where we've reached with Game On Engine. Yeah, so Game On Engine has been parked now. So moved on to the Heroes engine after our Lord and Savior Jesus Christ. So the idea is to build an engine that allows me to build content for making Christian based content. Basically, that's the idea. So that will be the plan. So the first sort of 6 months or so, we're building the renderer. So there's going to be meshes and mesh clusters and stuff like this. Procedural materials. So materials done at runtime, not done with textures. So procedural textures in shader code, basically, that's the plan. Yeah, working on this renderer for the next 6 months, basically, making it look very nice, and build an editor, and then go from there, really. Yeah, speaking of which, I guess we'll start with a quick prayer. Have you been, Rohan, by the way? Good to see you again. So yeah, we're making the sky render faster today. We've got this is the plan. So improve sky rendering performance. Either we drop the quality a little bit, like the number of samples, or we render gradually over so many frames. I think we're going to do a combination of both. And then we also want to have some kind of night sky, because right now it's just pitch black and it doesn't render anything because it's pitch black. So we probably want to add some stars like this, and we also probably want to try and have fun and put a nebula in. Right, that'd be kind of cool, with like a moon, and yeah, so we actually have light in the darkness. So that would be pretty cool to get that in there, and then we'll double check the PBR code to make sure it's all correct, because I think there's some slight problems with it. But yeah, it's the plan for today. Any questions, feel free to ask away. Yeah, so Holy Father, thank you, Lord, for this day. Give us the give me the insight and the intuition, Lord, to get this checklist that we have here done and effective, so I don't have to come back and rewrite this code and throw it all in the bin. Help us all have a good time today, Lord. Help us all learn, gather new insights today, and help touch the hearts and souls of these people, Lord, and let them know that you are real, you're the one true God, and that only through you their sins can be forgiven. Also pray If there's any mountains in people's lives which is causing them not to progress, which is causing any stagnation, we pray against that mountain. We say it shall be moved now in the name of Jesus. Thank you, Lord. In Jesus' name we pray. Amen. There we go, guys. So let's go ahead and get started. So here's the thing, right? Here's the thing. We kind of want to have the ability to render this sky over a series of frames. So if we go to sort of sky rendering, or render sky, there's a few things which are generated which can happen only when like the sky quality settings change or something like this. Yeah, I think we should add a few new sort of like settings. One should probably be the sky resolution, and the other one should be the number of samples or something like this. I don't know. Probably the sky quality. Resolution and quality, but isn't that, yeah, kind of tied together a bit? But yeah, I think maybe number of samples. You could probably say, yeah. So I think maybe settings, fine, just more Verilog stuff. Awesome. That's stuff I would love to learn, but I don't have enough time. Got too many other things I'm doing. What's have you sent something off to be built yet? So what are we? Yeah, this is the sun stuff, right? So manual sun direction. Good. So, yeah, we're probably on like a graphics sky resolution sky. We could do sky quality. I think we'll just do sky quality. So equally though, we could just have one called quality. And quality mode, so just gonna be in basically low, medium, and high. Right. So and I think we'll call that a graphics quality. Actually. So I have a graphics quality for the sky. So we could offer an option for maybe disabled as well. Because you might want to turn stuff completely off, maybe. But turning sky off is gonna like break everything anyway. But yeah, let's get rid of that. Cool. Right, yeah, there's this there is Codec engine that we sent out to Tiny Tap out. Nice. We should get this by June. Awesome. Oh, nice. A ROMless codec engine that utilizes SPI slave interface to receive 4 16-bit inputs. ATAN alpha X and Y and returns 3 16-bit outputs. Alpha cosine sine. Right. Nice. So something like visuals or graphicsy. Oh. Awesome. Right, shut that. Right, there's no VJ core in this design, but we'll add something on the next iteration. Oh, okay. Nice. Right, so let's regenerate the code gen for that. Beautiful. Now the next thing to do would be to go back to the sky. Now, so there's this sky lookup table image. This only has to be done on the first frame. We don't have to keep doing this. I forgot what the performance is on that. It's not much compared to everything else, but it definitely contributes. So we need to swap it out. So, oh, let's close that one. What I mean to do is this one. So the sky lookup table, yeah, 0.63 milliseconds. That is something substantial, right? So we want to stop this one. It's just some lookup table that's used for the sky rendering. Only needs, when the quality mode changes, this needs to be regenerated, right? So what we should kind of do is store in graphics VK. Yeah, I wonder if we should store like an invalid somewhere or something like that, or no. Yeah, so internal. We're gonna store in here. Yeah, we should probably put some of the sky stuff all together, but here we go. So graphics quality. I think it's maybe a V0 version 0. Where's the settings at? Include. There we go. So this would be sky quality, yeah? So when we set up the graphics system, what we'd like to do is say, right, your graphics sky quality is equal to something like U32 max or whatever it is, right? So just something invalid. Then when we're in the sky, render sky, what we can now say, Boolean generate lookup table, false, if generate lookup table. Now we want to say if ggfx dot sky quality is not equal to G settings, graphics, sky quality. So that can change. And then what I'd like to do is regenerate the lookup table, plus do some other things, hence why I got it in a separate if statement. Okay, so I want to generate the lookup table, step 1. So the other thing as well is we probably want to have some kind of like, I don't know what you call it, like a tick or something like that, or like a state. Yes, you probably have a sky generation state or like, yeah, so we probably want to keep track of like, there's a sky time of day thing. I'm not sure where that is anymore. I think that's that, yeah, the globals. Stuff to do, something to do with the global uploads. It's somewhere around here. Yeah, the sun direction. So when the sun direction changes enough, you want to actually generate a new you actually want to generate a new sky basically, right? So I think we'll probably have different states that it goes through and generates different parts of the sky at different frames. But then if the sun direction is still, then you don't need to actually change yeah, then you don't need to regenerate the sky again, basically, right? So the basic idea is you have this. Comes from the payload. Right, so we go to render sun, or sky, sorry. The basic idea is if we want this, is there like a world GFX, VK? Is there a payload in here from the game? No. So it would be nice to have this payload accessible somewhere. Maybe we pass in the world or the sun direction. Yeah, so let's pass in the sun direction unorm. We'll pass that in. All right. So I guess let's store some states in here. So there's a few different states the sky could be generating in. So the first one would be, just generate the actual sky. The next one would be generate the irradiance map. And then maybe the highest quality MIP or the reflection map, and then maybe the rest of the MIP levels for the reflection map. I think those are the different states I want. And then we can just tick through them each frame. So it takes like 5 frames to do them all. And that way it should just account for the performance there. So let's try that out. So we probably want to call it sky state. Enum graphics VK sky gen state, I guess. I don't usually like the word state. But then I guess the word state usually just means nothing because everything is state. So let's drop that word off. But maybe I'll put it back, I don't know. Let's just write it out. So sky gen. So the first gen we're going to have is none. Right, we don't do generation if we don't need to do it. The first state, if you will, of actually generating, or maybe we have finished at the end. Yeah, I think maybe we'll have finish. Yeah, we'll have finish instead. Okay, so the first one is going to be, generate the actual sky. Then the next one will be generate the, what was it again? The irradiance map. Then the reflection map. Reflection highest or MIP 0. And then reflection, MIP, etc. So just the rest of them, because they take progressively less time to do, right? So just do the rest of them. And then after that, you're finished. These are the different states. So I think we can SkyGen, something like that. So what we basically want to do is say if SkyGen, if ggfx vk SkyGen is equal to SkyGen finish, and the graphics vk, we should call it like have a float in this, SkyGen sun de unorm, we'll call it. So this is what it was yeah, maybe we should start it. All right, finish is probably not a good one. We'll do none. Yeah, so unorm, if that is different from sun de unorm, then what we would like to do is tick this off. So yeah, I won't do finished anymore, we'll change it. So I think we'll do none, because then it will count for the first frame basically. So we'll set it to generate sky. And we'll make sure as well that we store the new sun direction such that it doesn't keep happening after every time it's finished. Cool. So the basic idea is we will then do a kind of a switch. G graphics vk SkyGen. So none is going to obviously do nothing. Generating the sky is going to do these two right here. Generating the irradiance map is obviously going to do this one. Generating the MIP 0. This is etc. And then we do MIP 0. So let's make sure we get this right. So MIP 0 just wants to do, hang on a minute. There's no for loop then basically. The roughness is going to be 0. Dispatch. Cool. Now this next one. So the idea here is we want for the reflection maps, we want to skip the first one. So we want to make sure we divide this by 2. We want to have the custom resolution as well. We should sort that out. We'll do this afterwards. Okay. So then we want to start at 1. Now MIPS count, number of MIPS. Hey, Egotist, how you doing, sir? Hello. How have you been? Right, sort the roughness, dispatch, done. So this should be it. So now what we should be having is the sky being generated over a series of frames rather than just one frame. Oh, sorry, we should tick. We forgot to tick. So GGF, we've got to tick it to the next one. So then we'll do it explicitly rather than just doing +1, even though it is just effectively adding 1 to the enum. We'll make it obvious. Okay, so then, then etc needs to set it to none again. Now, what else are we missing? The lookup table needs to be generated first frame, which it does. Then, yep. So that will work. So the next one we would need to do is quality, is the quality settings and actually get the different resolutions. Right, so that was cool. I think that worked. Let's double check. So what we're seeing now, look at the performance. Okay, so it seems like right, the reflection map render is still very long. It's still 20 milliseconds if I get it on the right frame, but it's not ending. But at least it's happening. It's not even as well. You know what I mean? Maybe we might have to. Yeah, the Reddit map is still 10 milliseconds. It's a very long time. We might have to split even these ones up even longer, but I think, and it does make this go all over the place. Right, but if we stick the sun to be, if we stop it, yeah, it doesn't even impact the frame anymore. Just the yeah, it just runs at the frame rate of the yeah, it's v-synced, right? So yeah, dynamic sky. Yeah, I'm doing good. Thanks, Egis. Glad to hear you're doing good too. Amazing. Yeah, we got a dynamic sky, so it's all been it's rendered in the compute shaders. So the problem is it just is very expensive. So I'm trying to split it up across a few frames. That's the idea. Every time we update it, it changes, which is cool. And it happens over a series of frames, but at least it. Which is great. You know, it might be good to do the sky in fixed intervals of a certain amount such that it's, tiny floating point values don't cause it to regen, but um, yeah, stuff to think about. Yeah, we have it completely adjustable. It does. Yeah. That reflection map render costs 15 ms. What we can do is probably make it such that we could test the performance of each of these states. That would be great. Each of these different states we could test it, and that way, yeah, we could just see it in the profiler, right? Yeah, so we'll probably have another setting so we can see these, but yeah, let's do that, and they're probably going to be. So we'll probably call it Sky. Just do it U32 so I don't have to share an enum between this stuff. I could do it, but so Sky Gen override, and I guess you can say 0 is off, and it's just a one take, something like that. So the basic it's a range. I don't know what the range would be, but you could say 0 to, I don't know, 0 to 6 for now. Cool. So you basically say if ggfx vk dot sky. Wait, hang on a minute. If g settings dot skygen override. So if it's non-zero valley, then simply just poke it into skygen like so. Voila. And that way we can see it take an effect. Oh, take one. Calling algorithm to estimate sun position. It's approximation of. I'm not sure that's what the performance issue is, but Cordic. What is it? Trigonometric hyperbolic logarithm group functions. What is right? I see. Nice. There's a bunch of shifts and adds and stuff. Small lookup table. Yeah, I'm not sure that's where the performance bit on a bottleneck is. It's because it's like a physically based one. It does ray tracing and all this. I'll show you it. Sky. What is it called? Sky shader toy. There's one. You literally Google this and then do the physically based one here, or production sky rendering, one of those two. Yeah, this is the one that we got, and it's a physically based sky and does all this sort of ray marching stuff, and it's yeah, it's quite compute. It does like a spectral rendering as well. So yeah, that's the reason why it takes a bit to do that. We can see the performance for it in just a second, actually. But even generating the what would you call it? The different maps after, like the irradiance map and the yeah, right, let's see it. Oh, why does my rendering do that sometimes? That's not very nice. Right, so manual sum mode. Let's get the here's our boy. So we're gonna test that performance for generating the sky. Oh, They don't want to show up. Oh no, yeah, it's the lookup table. Yes, this lookup table. Nah, it's not right. It's not even there. Nah, there's nothing here. Right, no one then. Oh, because one would have been none. So it doesn't have to be a +1. Okay. A -1. Okay, so anyway, so Sky's Shade. That's 3.87 milliseconds. I don't know, what sort of thing should we do for this? And then the irradiance map is 10. Then the reflection map is another 10. That's good then. But they're kind of the same. And then doing the rest of them. Okay. So maybe we should break. It's kind of cool that they're. Yeah, 4 milliseconds is a lot though, in of itself. 2 tens. Tens is like, oh, super high. You want to break those down even more as well. All right, let's keep breaking them down. So what's another way we can break it down? So sky rendering, it's a 2K image. I think the first thing we should do now is probably add the custom resolution. So we've got different quality settings. So we should probably add what is the resolution of the sky? We could probably do, yeah, what's the wide? Yeah, the Y. We'll probably do the vertical. You typically do verticals. Yeah, so we'll get rid of these constants basically. Let's do that to make the resolution configurable at least. And then we can work on breaking it down even more by maybe shading part of the textures. Yep. So I think maybe we should try and aim for a budget of like a millisecond for each stage. And this is on this particular GPU, 1 millisecond. The sky rendering is probably quite reasonable. But we don't want to. But then the more we break it down, the more frames it takes to actually render the full sky up to date everywhere. So yeah, there's that. But anyways, so we want to add what will be known as the sky dim. So that'd be the y-axis. The x would just be ×2. And then I guess the radiance. Where is it? The radiance map x and y. We'll just call this the y then. Dim y. Then probably irradiance. Irradiance dim. Then the reflection. Yeah, so that's cool. Now, so if the quality settings change, what you want to do is switch on the quality. And handle that. V0 graphics low. Skydim Y to the lowest. Maybe we do, is 256 too low? I think it might be. So low might be 512. And then the irradiance. So irradiance is, so if your Y is, so it's like 32 times, isn't 32 times 32 1024, isn't it? Yeah, so if we've stepped down hard, so this would be 16 then. Then we'll just double basically. So medium will be 1024, will be 32. Ah, Amita, welcome. Thank you so much for the bits there, sir. Appreciate you. Appreciate your support. And then the high will be all the way, would be 2048. This one's gonna be a monster. But yeah. Ooh. We okay. So but there we go. So then also you'd want to actually recreate the actual textures. So if we go over to this sky, where they called the sky image. Now they get made here, but the problem is they're going to be made with kind of like a 1x1s. So sorry, they're made with the wrong resolutions, right? So we want to make them with 1x1s and then recreate them again, basically. So what we can do is make this a function, but then like yeah. So I think we'll make it a function. So what's going up here? We probably don't need that anymore. Yeah, I guess we'll call it static void graphics sky. Yeah, but then you have to reinitialize. No, I don't think we'll do it. Yeah, reinit is different from initialize. Okay. Right, here's what we're gonna do. We're gonna create these with ones. So time and time again. So reflection beyond, yeah, if that's different. Right, so what we want to do is now undo all of that. Copy what we had. And then I'll redo it again. So we want to copy all of that. Nice. So unfortunately, what we need to do is resize. Reinitialize all these images again, all textures, right? So render sky. Oh crap. Yep. Sky shading. So when the quality changes, this needs to happen. We need to throw away the old. It's called reinit. Is that a thing? Yep. If you pass in the spec, we don't need the name for anymore. Oh, okay. Yeah. So, right. So here, here, and here. We would like to take this old, or this name here, put it in as the first parameter, then pass in the spec. Now, these all need to be updated. So this would be G ggfx vk sky dim y times 2. That's the x. Then the y is ggfx vk dot sky dim y. Then this irradiance one is kind of similar, but it's irradiance dim y and irradiance dim y times 2. All right. So, oh, I forgot to make these reinitialize. Nice. So that recreates the images. They're going to be obviously black again or whatever it is. And with the new resolution, very cool. So that's great. Now we've got to chase around this constant, or these constants. So these constants here just need to be chased around. So in the sky shade, they've got to be passed in. So we could put these as like a global, and they're accessible everywhere, but they probably don't need to be used in many places other than this. Yeah, these. So in sky shade and sky lookup table gen, they need to be. Right, so that's one thing to remember as well, is when we change this, the sky quality, we also need to change the sky gen needs to be set back to none, and the sky gen sun direction u norm needs to be set to something that is invalid. So we could just, which is going to cause a change. So we can just say +1, right? So that will cause it to start changing again, which will be cool. Then yeah, the problem is though, is the generating the lookup table is going to be 0.6 milliseconds, which is kind of at the target of our 1 ms, 1 millisecond thing, you know, so maybe, yeah, that's kind of at the range. So maybe that needs to be another state that it needs to be transitioned through. Yeah, I think so. So, but not really. Yeah, it does. Okay. Got some ideas. So, right, let's just keep chasing these around and then we can sort it out. So, right, so ggfx vk sky dim y times 2. Now, see, part of me just wants to call it sky dims and then call it quits. Yeah, I don't know why I'm trying to save. I've already started doing it now, I guess. We'll just live with the times 2s everywhere. Yeah, okay, we'll do that. Alright, so ggfx vk sky irradiance dim y times 2. Okay, ggfx vk sky radiance. Cool. So let's see what other. So there's only one place where it's being used, and that's in here. So we can just delete these here now. Yep. Now the skybox though is going to be in two shaders. So sky shade and lookup table. Oh, and the reflection map as well. Okay, so hang on a minute. Okay, so let's get rid of those here then. So in the push constants, they need to go in here somewhere. So take these with the skies. Oh, you already got dims anyway. Huh. Right, so dim's already been passed in. Then sky shade. Yeah, these need some dims. So we use the packed vector. The scalar aligned rather than vector 2s, which are not scalar aligned. These are let's call it dims. Nice. So nice. So yeah, you know, Parmes wants to do this. Yeah, so a 4K sky, that's gonna be so expensive. But there we go. This is the way. Yeah, then the irradiance thing as well. Sort that one out. Nice. So 32 on the XVU, and then 64, 128. So that would be cool. That's nicer at least. So we want to pass these in. So when we generate the sky, so sky shade dot dims equals gfx vk sky dims. Yeah. So it's passed in. That's nice. Radiance is already passed in. Then it's already passed in for the reflection map as well. Okay, So, what else are we trying to do now? So that would be... Yeah, we're going to sort out the shaders. That was right. So it was like skybox, sky. Yeah, skybox dim. This is the one. So this is already passed something like IVEC to underscore PC dims. I think that's right. Then, oh, we've got some more here. Yep. Cool. Right, next one's skybox, the lookup table, same thing. Yep. Amazing. And the reflection map render. I don't know why I didn't catch this, but we should be using this push constant dims.x times push constant dims.y. I used the constant for some reason. Okay. Amazing. Amazing. Right, so that should be everything updated. Now we've got a configurable resolution on the sky, which is a big help. This can help with performance as well. Okay, well, it turns out it doesn't. It's just a white screen right now, which is obviously super helpful. The sky image is black. This is why. So it's... Yeah, something's wrong. So if we fix the sun direction, it still doesn't resolve. So it seems like it's going through... We check the performance counters. It's not really generating much, if anything, for some reason. Why is that? So you know, it does. So it goes through this, right? You're going to store some kind of different value for the sun direction mu norm, and then at the quality, the lookup table will be generated first. Then this will come into here. There shouldn't be an override. And then it should just go through this. Right, so it should go for each stage, but it's not. But it does seem like it does show up for the first so many frames, I think. I don't know. Yeah, so you see it is ticking through stuff, which is great. But then like... Yeah, it's going through stuff, which is great. So why then... And it is doing like a sky shade on this thing, so it should be showing up, but it's not. It is at this 1024 by 512 resolution, which is cool. You know what? We're probably not passing in the dimensions or something like that. Oh, into the lookup table. Yeah. So the lookup table is completely... Yeah. We missed one. They didn't get the sky dims. Cool. Give that one a go. So yeah, we're at this sort of lower resolution right now. So the sky's at an even lower resolution, but that's cool. We check the performance. we can't really. We get the sky up, or the settings up. We're going to fix it on to a fixed sky, and then we can see override. So the sky gen for half the resolution each side obviously takes, it's 4 times quicker, right? Because it's 4 times less pixels. So that takes 1 millisecond to do a 1K sky. My problem with this is that, what's my problem with it? Yeah, the resolution isn't that great. That's my problem with it. And I've crashed it now. Crap. So we should probably try and measure everything around the medium quality sky, because this card that I'm on. Should we do that? Or do we want this card to be like the minimum spec? Yeah, having a 1K, having a 512 sky isn't really. Yeah, we should probably try and fit everything on like medium by default. I think that'll be wise. Let's go to the settings. Let's default that to medium. Yeah, it's default to medium. Right, so now here's the next thing, right? The lookup table takes nearly a millisecond to do. So ideally we want that to be a state that gets done. So we'll try and make each of these be a millisecond each. And that way Sky only takes 1 millisecond per frame. But we've gotta change some things. So effectively when you change, you want to do the sky lookup table first. Sky LUT. So you only change the sky LUT, the lookup table, when the quality changes or the first frame. And then we transition to the gen sky the next frame. Now, I've got to be extra careful. Yeah, so now this one takes 4 milliseconds. So what do we do? Right, I guess it takes more than 4 milliseconds. Yes, sky's on medium by default. Beautiful. Right. Let's fix the sky into a certain place. Let's bring up the profiler. So nothing's been rendered on the sky. Now we flip on 1. We've got 1.12 milliseconds now for some reason. Okay, it was taking anyway. Yeah, 1.12 milliseconds for that. So that's within the budget. That's good, right? 1 millisecond for sky. Next one. 4 milliseconds for sky shading. So if the skies takes 4 milliseconds to render, that means we need to split it up into 4s to then get it into the 1 millisecond budget, right? So, or we need to tweak the shader such that it's not taking that long to do. So there is tweakable parameters within the sky shade. So sky shade, there came some configurable parameters with this guy. So there's these ray marching steps, like transmittance steps and in scattering steps. It's all the ray marching stuff. So we could tweak around with this and see. Yeah, we should also say if you've hotcode reloaded, regenerate the sky from the beginning again. Yeah, we should do that. So this one is part of the lookup table generation transmittance. So that one's already taking. Yeah, I think that's already good enough. You see, I wonder what if we could, if we boost it up to 256 threads, does it change the performance? Yeah, can we try that quick? I don't think it will, but let's give it a go. So if we, let's just double check we're still getting the same numbers as we did before. So that lookup table, which is the first stage. So we fix the sky, we put it to 1, and then we bring up the profiler. 1.08, that's not reliable. Because it was at 1.1, yeah, 1.12 before. Yeah, I guess so. I guess maybe somewhat reliable. Right, so the thing I wanted to try quick then was say if we changed it to 16 by 16 tiles, does that help? It might be very negligible though, but I will take negligible win. If, well, no, I won't take negligible win. I'll take if it's small but I can notice it, I'll take it. I'll take it. All right, so here we go. So, so manual sun direction. No, I can't even see. It's the same number. Right. So, okay. Right. So where we're going to next. So we can change this transmittance steps. Now, we want to change these, then it's going to hotcode reload. So we need to actually make sure the sky does update when you hotcode reload this. Is that fair? Well, we could just change the sun direction manually. Because if we hotcode reload and it constantly changes the sky for every shader we reload, that's going to be annoying as well. So maybe, maybe it doesn't matter. It might do. So if you change some shader, yeah, I think it's fine. So we'll do it. So there's a reload. Yeah, I think we should put the payload in the. So I don't have to keep passing into every single function, right? It's just there and usable. So in the payload, we want to get access to. If the shaders have been requested to be reloaded. So if that's the case, we want to regenerate everything anyway, right? So if, yeah, but then the override is going to come and mess things up, but I think that's okay. So if GFX payload reload shaders, I think it is, then just do everything from the beginning, please. Yeah, that'd be nice. So we can test this works by simply just fixing the sun, and then we can like multiply the we can change something in the atmosphere or something like that. We can be like, okay, sky shade, let's just fix the red color, like the color red to 1. There we go. So that changed and regenerated everything. Yeah, that's kind of cool. But yeah, so it works. Now the next thing I want to try and do is sort out the performance for a particular stage. We would like to see, I guess we don't need that one. Settings, this one. So we would like to override the lookup table. I think we're okay with that, so we can leave it. But the sky shade. If we bring up here's our sky. Look at our sky, doesn't it look lovely? Now, I think what we want to try and see is like, if we change something about this, the ray marching steps, do we see a difference? I think is the thing. So we go to the sky common. There's this sort of like in-scattering steps. If we change that to 16, what happens? I don't really see a difference. What's the performance like? Well, I think it's thrown a wrench in the gears of the performance. Oh, no, no, no. It's only 3. It says 3 milliseconds still. Hit reload. I don't know if it reloaded. Let's try and make it red again. Alright, now it's gone down to 2 milliseconds from 4. So it seems like if you half that number, it gets twice as fast, which is interesting. So 2 milliseconds though. Yeah, I don't know about the... It's hard to really... Oh. The problem is I've got HDR. So these screenshots in Windows suck. They suck so hard. It's too overexposed. It's annoying. You know, I could... I think I've already got a screenshot. I used to have a screenshot tool. Could bring that back. Hey there, Decision Clan. Yeah, it's just handwritten, so it just uses the Vulkan time marker things, whatever you call them. So we just go to GPVK. Yeah, so I just read back timestamps basically. I've got a tree of profiling scopes, and what are they called? They're called the query pool. We use the query pool and the yeah, what did you call it? You emit these, yeah, these write timestamps. You write one before the command and after the command, and basically you get back all your timestamps, and you can convert them into milliseconds and stuff like that. So it's pretty cool. It means that, yeah, I wouldn't call it a, yeah, it's not necessarily like a super cool profiler that does all these features and that, but it's really great for just in the engine being able just to get just a number or of how long it roughly takes for that pass. So if it's a compute shader, that's a pass. But if it's obviously draw commands and stuff like that, it's like the whole render pass. So it has its limitations, but you know, for 90% of the profiling that I want to do, this thing is just gonna, yeah, it's just super handy. And yeah, I can just pause it, inspect it. Obviously, has bugs. But yeah, super handy. So yeah, I guess we could drop the in-scattering down to 16. I don't know how that affects the visuals. You know, can we stop the camera moving for a minute and just look? Is there a sign in there? Radians of 90. Let's go the other way. Change distance to 32. Bit fast, don't you think? Here, I'd like to see if there's any clear difference changing the in scattering, sky common, 32, sky shade. Let's just put a new line in there, save all. Oh, that did make a difference, I saw that. Yeah, so it looks like it does make a quality difference. Right, so what we can do, yeah, I don't think we want to change that. Let's try it again. Clear. How much are we up at 64? Yeah, not that much of a difference. 32 seems alright. So it takes 4 milliseconds to render the sky then, using the sky shade thing. So we just got to break it up into fours, maybe. Maybe you say 1, 2, 3, 4, and we just go through the 4 different segments. That shouldn't be too hard to do. Adds more latency though. It'll be okay. Thank you. Yeah, they're really, really great. Like the texture viewer as well, super handy. I've got more things. I got like the ability to like debug draw and stuff, and like from shaders and print as well. So yeah, super handy. Super handy. You just got to be you know, like sometimes you can always do like another tool. Like right now, I can do with my screenshot tool, which I used to have. I need to get that back in the. You're like, you know, but yeah. Right, so sky. I think we'll do sky 0, 1, 2, and 3. So just the 4 different parts of the sky. We'll subdivide it up. Now the thing is, you probably want to pass in some offset. So we'll do like, yeah, the issue is when you start doing parts of the sky, are you gonna see tears? Or you know what I mean? Like you're gonna get portions of the sky now looking a bit, you know, one frame you're gonna have half the sky done, and then the other one comes in afterwards. It might be, you know, the sun's gonna look a bit divided maybe in cases. So yeah, that might not be a sensible thing to do. Right, what other things can we change? So yeah, it's obviously this stuff here. Sampling. Look up from a texture. And there's another lookup from a texture as well. Twice, 3 times. And that's where all the cost is, isn't it, basically? Yeah. Yeah, that's where the cost. Let's take a look at the sky image. I think. So to split this into 4s, I guess it might not be that bad. Yeah, I think it's fine. So if we split the sky image into 4s. Yeah, so it might be fine. It might just work. Let's do that. Okay, so if we split the sky image into 4s, then I think 0, 1, 2, 3. So what we want to achieve is effectively Probably some kind of like offset. Offset equal nothing. Go to sky. So that would be graphics vk skydims.x. So we're doing like, it's just half across basically, right? Then this other one is going to be down by a half. And this other one is going to be both, isn't it? So it'd be down by a half and then both. Yeah, in the corner. Then so you want to pass in an offset. Now yeah, something like that. Now you're going to be doing half, like just a quarter basically every time, yeah? And it's going to be powers of 2, so it should be fine there. And then you only really want to do this one, this down sample, when GGF, and this is basically going to be free in terms of like, it's so quick it doesn't matter if we do it on the last one. It just adds, just to like the down sample is going to be super cheap. If that one's equal to the last iteration, done. Now we're just going to keep adding one to this every time we come round, and then that'll go to the irradiance one eventually. So nice. You see, I wonder whether or not we should add steps to these phases as well. Maybe. Like a substate, maybe. Because, yeah, I think we should add substates, maybe. I don't know. Or maybe not. Yeah, maybe a substate would be fine. Hmm. So, yeah, then that means in the sky shade, effectively you just add the offset. So you do your swizzle. So that'll be ivec2 underscore convert the offset and add that. There you go. Lovely. Right. So the irradiance is probably going to need to do a similar thing as well. Oh no. What have you done? Right, so it seems like it works, and it's a bit it's a bit laggy. All the way it looks is very laggy. Downside is we cannot generate move the sun very fast without it skipping. That's okay. Sun doesn't move that fast in real life anyway. yes, so 1 millisecond there for the sky. Lovely. Right, next one, 1 millisecond, 1 millisecond. And then it's got down sample in there, 0.15. We'll live with it. Right, and here's the next boss to tackle. The irradiance map render. This one's 8 milliseconds. So we can now play around with this guy. So here it is here, this image. It is just a single image and it's very small, but it basically does a lot of computation because it's generating a Did I change the number of samples? Why is it 0? Oh, the sample delta. Yeah. Yeah. So it's effectively doing a hemisphere. So a hemisphere is half a sphere. So for every, this is just a sky map. So for every point in the sky map, get a hemisphere and launch rays around everywhere and collect up a diffuse, the sort of ambient, the diffuser radiance, right? So essentially it's the ambient lighting in the PBR stuff. So for this, if we move the sun, right, you'll be able to see it. Hang on a minute. Hang on. Yeah, there's it at the horizon. So obviously when you got your pixels there that pointing towards the horizon, the sun of the horizon, the hemisphere's gonna be pointing away towards the sun, isn't it? So it's gonna get a bit bright there, so you see it. Now, so if we change let's keep this up. Let's change some numbers. Let's change this by 10. Right, clearly it doesn't look as good and create. So we need that step size. We need, we increase it by another 10 times. It doesn't really change that much, but it becomes stupidly slow. So, right, so it's gonna cost 8 milliseconds. That's it. So that means we have to probably portion it into eighths. So I think what we should do here is this one probably doesn't matter as much as the other one in terms of how it's segmented. We could probably do strips, like horizontal strips, or columns, just across this here in columns. And that should be fine. So we'll work on that next. It shouldn't be too bad. And then we'll have to do the same thing for the reflection map, probably in some way. Right, let's take a quick break, and then we'll come back and do the BRB. Right, welcome back. Welcome back. So now we've got to add steps to the irradiance generation because it takes 8 milliseconds. So we just do a simple divide by 8, or divide into 8 sections. Now we already did it for this sky gen and we added all these extra states. And I don't know if it's going to be a good idea to, maybe we just have an extra variable instead rather than, I don't know, maybe like a subgen, right? Maybe it's like sky subgen. If we did subgen, then it would mean no, I think it's fine. Just do a big old enum like this. Does the job. Right, so 0, 1, 2, 3, 4, 5. I can teach my son to count. 6, 7, 8. Oh wait. Yeah, that one. Now, so the offsets for this one is simply just going to be across. It's not going to be a 2D thing. We'll just do slices, columns. So in this sense, let's put the offset in first. So it's just going to be 1. So it'd be like a offset X, right? So in irradiance map, it's just going to be IVEC2 PC offset X 0 plus that. Yeah. And then we simply just do offset X is equal to hang on. 4, 5, 6, 7. So it'll be whatever this is. Yeah, so it's GFX VK SkyGen divided by wait, what's it divided by? Take away this, so that gets us the sort of like a 0 to 7 number inclusively. Multiplied by the step. So the step is going to be the irradiance dims. Hang on a minute. How big does your irradiance dims get? Oh, 120. Oh, 64. So they do divide by 8. Yep, that's good. Good. Nice. So that'll be your X's. So you probably want to call that your sort of X dim. So it'd be like hey Davros, how you doing? Does it still use HTC SPIVy? I do remember rightly this rendering was done using that. Yeah, so I ended up uh parking that project basically because it was super cool and it's sad, but it was eating up a lot of my development time because what would happen is there'll be like a new version of SPIVy tools where they'll like update uh the some of the rules in the SPIVy specification, and then that would cause me to like have to rewrite parts of the compiler to account for this new defined rule they've done, or I would what else would go on, or I'd get to the point where I need to add, or would write a lot of code, and there would be some edge case that comes in, and then that would reveal a problem of how I architected something in the compilers. I'd have to go in, and then I'll just be accumulating some sort of like tech debt. and I have to like rewrite it basically at some point. So unfortunately, like because it's just me and I kept bumping into these problems, it kind of got to the point where it's like, yeah, I would, I just suck up and just used, you know, one of the shading languages which suck for the time being, unfortunately. But the core idea of the project was just to sort of show everyone, it's really cool if you can write in your CPU language on the GPU. Can we do that? I was hoping that people would more of like, take the idea and, get it into like these into other compilers and basically hopefully inspire people to do that, because for some reason it's 2026 now and we still don't have it. um Leave it as a challenge for people who think AI could write all the code, maintain this compiler. Yeah, exactly. It's simple, right? Just tell the AI to maintain the compiler and it will do it. Exactly. But no, yeah, it's not all hope has been lost on it, because there is other, you see the Clang guys, I think some AMD people trying to get Clang to work with like shader programming as well, but it's mainly around the compute side because obviously AI probably. But they, but yeah, GPU programming just sucks, unfortunately. Like, it's cool what you can do with it, but the interface to do it kind of sucks. And it's just the way it is. Yeah, I wish we didn't live in this world. I'm honestly betting on Jesus Christ coming back and hot potsoing us up out of here before shader programming gets better. But so yeah, that's what I look forward to the most, really. uh, yeah, I'm laughing because I actually believe it and it's true. But there we go. Yes, there's no hope. No hope. um, is it divided by 8? Yeah, that's right. But yeah, so we're not doing the ellipsoid rendering as well because I want to make games or visual content for um for the gospel, basically. Not really the gospel per se, but Christian based content. So ellipsoid based art style, probably not the best idea. So yeah, that's been replaced as well. We're going to be doing just doing meshes, cluster based rendering, but we're going to be doing an editor with sign distance field shapes that get turned into meshes and get chucked into Mesh Optimizer, and it can generate the clusters for us. And it'll be cool. It'll be really cool. So we're working on that very, very soon after the material work is done. I'm just sorting out the sky rendering because I've just made it slow, like stupidly slow. So sorting out sky rendering, materials, testing out procedural materials, like making like wood shade, like a wood procedural material and some metals and stuff like this. And then we'll just be doing the SDF to mesh thing and getting that sort of build pipeline all in there, and it's going to be cool. And then we'll get some editor where we can like make a thing. So we can make some things, because who doesn't like making things? Rightio, so we just want to increment that by 1 then. I think that's sensible enough. That should do it all in different little segments. Did I change the settings thing? So let's change the override to be much higher. I don't know, 32 is probably that. If it's 32 steps, that's nearly a whole second it'll take to do a... Oh yeah, that's the thing, isn't it? We have that. Oh no, it's not that many. Um, it might be though. That would be a bit long to converge, but then again, it won't be. That'd be fine. A second to converge. Let's do it. You know, the sky's not going to be moving that fast. Just move it slowly. Go. Fine. It'll be fine. So let's get the profiler up. Ooh, no, we'll keep going. Keep going. So here we go. So we're looking at this sort of side here, right? So I've got one. When it's one or more, it's overridden. So the sky lookup table is 1 millisecond. Great, that's the budget, basically 1 millisecond. Sky shading, we've got 4 of those guys, and then the irradiance map renderer takes 8 milliseconds still for some reason. Why? I messed something up. What did I mess up? I thought I divided it by 8. What's going on? Tell me the reason. You should be doing like like an eighth of the thing. Eighth of the thing. What's going on? It's launching an 8th, right? When does it ever do this? They're gonna crash? Because right, it's out of bounds, maybe? So if we made the offset 0, what happens? Offset 0 would just be comment at the line out. Do, 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 do. Yes, there's still 8 milliseconds. Okay, so if we... Why no work? Oh, wait a minute. It's because the divide roundup still dispatches a group and then it's still in bounds and then it's going to do an over... Crap. Yeah, so the problem is the numbers are so small anyway. It's going to still try and complete them. Yeah. So how big are the numbers? So on the medium, if you divide the x by 8, you've got 8. Right, and then it divides it by 8. And then it does a 1. Oh, it should be fine still. But the 32 one isn't going to be enough. Hang on a minute. Yeah, maybe we might do a 2D grid thing again. That's not... Do we do... If we divide by... Yeah, I think we'll do a grid again. Okay. Because we did a grid... You know... The irradiance map... Right, so xdim ydim. So if you got an image which is typically twice as wide than it is tall, you could probably split it into 8s. So 4 on top, 4 on bottom. Right, so it's divided by something like that. And then you want your kind of like index, I guess. Yep. Now, so to compute the offset, it's probably going to be a mod. Hang on a minute. Okay, so xdim. So I mod 4 times xdim, something like that. And then ydim I divided by 4, I think that's right. So yeah, when it goes past 4, it'd be 1, wouldn't it? Yeah, so it's either 0 or 1. Cool. Nice. So then, now the question you gotta get ydim. So when we look at these, if that gets divided by 2, that will still be 8, as in one whole group. It might just work out then. Okay. That should evenly split it into 8 tiles. Right, let's give that a go. So that shouldn't be 8 minutes. It should be... Oh. What happened here? I see. Right, so something's going on. Let's see what that is. Okay, so we're bringing this up here. It's still 8 milliseconds. Like, what's going on? Why? Why don't you like it? Yeah, so what's probably going on is it's doing an 8x8 within the thread group. How big? And it's going over and doing too much. Can't be. So if it's a 64 by 32, so you've got 16 going down. That's 2 groups. Yeah, something's really weird is going on. Do I have to pop in the debugger to see this? Your widen would have divided it by 2. And your extend would have divided it by 4. Yeah. So that would have divided by 4, making it 16. So 16 divided by 8, you get 2 groups. So why is the performance? Yep, I'm confused. Right, let's open up in Red Debugger then. Oh. Render sky. Right, let's pop in and see what's going on. I'm confused. Okay, so 16 as we thought, right? 16. Yeah. Okay. So that's two groups, right? So PC offset 0 0. Good dims. Yes, those dims are going to be a bit bigger. That's okay. 64 by 32. That's fine. Because that's not the full dims, but the dispatch dims is just going to be 2 groups along the X and 2 groups along the Y, making it 2 groups of 8, making it 16 by 16. So why is it taking 8 milliseconds still? Considering if we put in, we used to put in the full amount of this dims, it would be many more groups. It would be 8 groups. Like, it's nothing special, right? It just does the offset plus whatever your local offset is of the 8 by 8. If you go outside the image bounds, just exit out. There'll be 2 groups launched, or 4 groups, sorry, 2 on each axis, and it does this. Let's launch in the right shader. Right, let's try. This was supposed to be simple. All right. Yeah. Right, so let's revert it back basically, you know, get rid of the offset and then right, let's give that a go. So we'll bring up the settings, fix the sun. Get the profiler. Yeah, so here, see, it's 8 milliseconds. Oh, is it doing many of them? No, of course it's not, it's just doing one. Okay, so doesn't look like I'm doing anything dumb, I don't think. If I change it, it reloaded. Oh, and it's just frozen and crashed. And yeah, so still 8 milliseconds. Is it because it's cached? Do you reckon that's it? So basically doing the full image is cached, so it ends up basically the same. That doesn't seem... It can't be, can it? So this is like 7 milliseconds, yeah? Then if we... No, it's frozen, so it's about 7, 8 mil. Then maybe a hot reloads. No, it crashes. So maybe it could be something to do with caching. Like, so the image that's being made is very small, but it does tons of sampling. Could it be that there's a lot of cache reuse and at some point, I don't know. Doesn't seem like it. That's my other theory. But then why? There's just tons and tons and tons of samples. Okay, so it's about a millisecond. I don't know. It's in the same rate of variability, I think. At 7, 8. Swap to the new one. Swapping over and about the same. About the same. All right, here's the other test. What happens if we use this one, but we purposely divide it by 2 on each of these? Does it not complete the full image? And then if it doesn't, has the performance changed? And if it, so these are some good questions. So here we can see that it hasn't done the full image, it's half the image. We can see it back in the pro here as well. Okay, so it's not done the full image. So now we look at the profiling. Okay, it's still 8 milliseconds. Right, that's kind of... So it seems like then there's a ridiculous amount of like cache reuse or something like that. I don't get it. So it keeps sampling this environment map. And I guess because you're running, yeah, I think that's what's going on. Yep. I see. I see. I know what's going on now. So what the problem is that, yeah, it's very, very obvious now that I'm looking at it. So here we launch 8x8 groups or something like that. So we're launching many different compute units, and they're just running in parallel on the GPU, right? And the bit that takes the most time is the shader, is the compute shaders themselves. So if we basically just have one compute shader running, or it's not really one, but we're having like a 2x2, so we're having 4 running, that takes the same amount of time to complete as having 64 of them running all at the same time, because the compute unit, the GPU that I have can be running kind of that many and sort of swap them. What's it called? It's called when a computer shader gets to the point where it's bound on memory, it can swap in another one to carry on basically. So it's able to hide the latency very well and do many at a time. So the problem isn't necessarily the amount that um, we're launching. The problem for these Radiance maps is the fact that it's doing lots of work on a single compute unit, and that's the problem. So what we need to do is change the shader such that it can somehow... Okay, so it's accumulating the irradiance, and then at the end we want to kind of store we want to like basically divide it by the number of samples. Now this number of samples is probably quite high. So we can't necessarily just accumulate it all into the texture and squish it down, because it probably goes down to a 16-bit float, and that might lose some precision and cause some problems maybe. Yeah, so we could do some... Yeah, we could split... I see. And we can't reduce the number of samples because we tried and it looked terrible. Yeah. So what do we do? 8 by 8. Each thread is doing a different pixel. So if you change it, see, I wonder if you could focus tons of threads on a single pixel. So if you did each thread group does 8 rays or 64 rays, 64 rays per thread group, rather than each thread group doing 64 different pixels. Could that be better? That would be one pixel per thread group instead. If you did 1 pixel per thread group, that could then mean you could still launch many thread groups. I wonder how that would change it though. Hmm. Yeah, maybe we could just squash it down into float 16 and it won't be that bad. Or yeah, okay, I've got an idea what we'll do. You can know how many samples that you do anyway, and we can just pre-divide it and atomic add it in to the end. Sorry, do an additive blend. Something like that. Yeah, okay. Right, got me some ideas. So you could probably do the 2 times pi would be like 6 point, it's like 3.14 times 2 in it. So the delta of that is 0.025. So the phi steps would be 251 steps for that. And then the x steps would be 4 times less than that. So it's 62 steps. So it seems like it's doing 62 times 250. Yeah, 62 times 251, basically. So it's about 15,000 steps per pixel. Okay. So I think what we can do is pre-calculate the amount of steps it's going to do in each of these for loops. And yeah, so which one was the longer one? So we want to take it, we also want to make it take 8 times less. Basically, that's the idea, right? So if we want to make it take 8 times less, we could take the we can make this happen 8 times less, basically. The idea. and then read and then store it back in, something like that. Yeah, I think that's what we'll do. We'll still do the full image, but we'll just make it accumulate over 8 frames. That's what we'll do. Okay, so it's this one here. But part of this irradiance thing will say like basically how many you'll have, what step we're on, and how many steps we want it to take to complete, something like that. So your step is going to be this, and the steps to make it complete is 8. Nice. Now the next thing to do is the irradiance thing here. So effectively what we could do is we can get the phi offset, I guess, is going to be step we'll call it a phi step, maybe phi phi max. So a phi step is going to be phi max divided by the number of steps. Then the offset is going to be, what step is it, times the phi step, right? Yeah. Cool. So now we just got to make it accumulate. That's the issue, right? We have to make it accumulate inside this image here. So the first time we write to it, it's going to be a store. Yes, the first time we write it's just going to be a store. The second time it's going to be an accumulate. So yeah, we might have to sort this out as well. So the other thing as well is this has to be it's now a read write rather than a write only. Okay. Now we need to do a load. I need to make sure we accumulate that. Something like that. Right, it's the number of samples. We then multiply the number of samples by the steps count. Think. Right, you got to scale it up. Yeah, so Right, I think that's right. So to get this irradiance, right, we start. That's the phi max. Phi max divided by the number of steps is, yep. Now you don't go all the way up to phi max, that's wrong. You want to go up from to the next step basically, right? You want to go up to the next step. Cool. Now and after we get the samples, we want to multiply it by the number of steps because you've got like let's say we've got 8 different steps we're doing this in. We've got 8 less samples, right? So we times it by 8 to get the overall number of samples. This could just be a constant, by the way. Then we won't have to do this. So we could just pre-work this out by saying, yeah, we could pre-work that out. So if the theta right, and then basically the number of samples is simply just how many times does sample delta go into yeah, so phi max divided by that times by theta max something like that. That's your total number of samples. No times by that required anymore, and this should just collapse down into a constant, right, if the compiler does its job. So yep. And then we're just doing to do an inverse of that. Okay, so now if your step if PC step is not equal to 0, we load from the same current pixel and accumulate. And then if not, yeah, then we just store it back in. So I think that's all we need to do. Bit fiddly, very error prone, that's for sure. All right, so number 10. All right, so we don't have this anymore. But that should be what we're looking for. So, right. Let's sort out the sun fixed. Cool. Put it around the horizon there. Now let's see the image viewer. Right, I think that's looking good. Like this is what it was basically looking like before. Let's move it around a bit. As you can tell, it takes a few frames. It accumulates over 8 frames. So I don't think this is a problem. The issue is it overwrites and makes it black. And that might make our whole scene look black and weird for a while it's updating. It might flicker. Every time the sun moves, maybe it causes the ambient light on the balls to change, which might. Ooh, we've got to play around with that. But I think it's sort out the performance. We'll see. I cannot see it. Maybe. Maybe I am. Right, let's fix the sun. So I think the problem is we're not seeing it because these are metallic balls. So if we go to the shade, scene shade, and switch out to the dielectric material, right, the plasticky one, whatever you want to call it. I think I'll call it grass because it's like a grass color. Now if we change the sun, yeah, you see it's causing them to flicker, you see it? That's not nice. That's not very nice, is it? No. But how's the performance? That's the important question. Did it really fix the problem? So we change it. All right, it did make it 1 millisecond. So that is great. The question is now, how do we solve the flicker? And why is it why is it glowing super hard? What have I done? Oh, that's because it kept on it kept on when we test the performance, it just accumulates into the same buffer. Right, so this is interesting. What could we do? So another way to do it, right, you just have two buffers, right, and you just double buffer it. It's a very small image, so we could just double buffer it, right? When you get to the last one, write it out to the final image, voila. That's the solution. So the thing is, look, small image, 64 by 32. Not that big. So the solution is just have two. Build in. Yeah, easy. Easy peasy. But is there a way that we can reuse the same memory? Some little trick. So you know, so it's you start building from scratch again. Could you somehow have the old data sitting in there, accumulate it, and then take it away at the end? Or then it just means it keeps getting brighter and brighter and brighter, doesn't it? Right? So what you could do is, oh, this would be fun. Oh, this is incredible. You get the original color, what it was before. Oh no, you can't do that, can you? You have to have another texture somewhere. Yeah, I was thinking you could take the original color at the first frame and then take it away once, you know, evenly every iteration that you do it, but you can't store it per pixel across frames somewhere without putting it in a texture somewhere. That wouldn't work. Ah, um, but yeah, it's interesting. It's an interesting problem. We'll just do the other texture because it's like the easiest thing to do. But it's a shame we need two textures then. Yeah, I wonder what we'll do for the reflection map then, since that's got the similar problem. Yeah, the reflection map has a similar problem, I think. Hey, Corabea. What's the Kumbaya? Oh, Kumbaya, right, I see. Yes. What does that word actually mean? Oh, maybe I've seen it in the past. Because it ends in Yas, because it probably means, you know, the name of the Lord, Yahweh, right? Maybe. Oh, it means come by here. Right, it's an African American spiritual phrase meaning come by here. Interesting. Yes, it's come by, oh my Lord, so as in Lord, come by here. Nice. Yes. How you doing, Caravia? Welcome, welcome. Yeah, so I think this one has a similar thing, right? It has a high number of samples, and you're doing that across the whole image, therefore takes time. So what we're doing is splitting the sample count out and getting some accumulated weight. Now the weight in this is dependent on this sort of n.l, unfortunately. So this one's probably going to want to store it. Yeah, we're just going to have two images, build it up in a temporary image over a few frames, and then swap it in. I think that's just the price we're going to have to pay, although it's going to be double. Yeah. There must be a better way. Yeah, I think you're probably going to have like an irradiance map rendering thing, and that will just have its own texture that it does it in and then copies it to the destination target when it's done. Same with the reflection map, because these are probably going to be, you know, I don't know if we're going to have reflection probes and stuff like this, and these will use the same shaders to do those. It won't just be the sky map, it'll be maybe the scene. So yeah, it just depends if we use those things or not. So, but yeah, so for now, we're just going to do so accumulate. If only we didn't have to optimize, eh? Yes, the basic idea is we build into so depending on so you can have like a 0, 1. They're the actual ones. And then when it's done and ready, so when the final one is done, so if this sky gen is equal to the final one, we store whatever the image ID is at the end. Yes, the basic idea would be if so it'd be something like GPU VK image ID. Hey there, hey man, how you doing? Welcome, sir. GPU VK image ID, and we're just gonna say that's the image ID. Now, if the irradiance image ID is equal to the first one, so the current one which we're displaying is equal to the 0, 1, we're going to want to use 1 to build with. And then if not, we'll use 0 to build with, right? Double buffering. So read write with that one, and then at the end we swap them over, so you commit it, and then voila, right? Easy, easy peasy. So that should solve the flickering problem. Now I've got to do my dot rules everywhere. Or just here, because it's a wrapped structure, so we get distinct types. Okay. Right, so alright. We now got 2 irradiance images basically. And if we take a look at the manual sun, so now we shouldn't see any flickering. Yeah, we're not seeing any flickering on these balls anymore. We used to see it for the ambient lighting. We're not seeing it anymore. It's definitely lagging in terms of when you move the sun, it doesn't respond right away, and it can come across as quite have like steps. You know, it's not smooth, but that's okay because I'm moving the sun fast, and the sun is going to be moving much slower if it's going to be moving at all, and that's the price we're paying with this. We want it to reach good performance. We have to have this as a cost, and that's fine. So now we go and see the irradiance map render. It's taken around a millisecond budget. It's a little bit over, not gonna lie. That sucks, but it's okay. We could probably change the steps to make it 9 steps, and that would make it fit within the budget. Now the reflection map render, that's the whole other one. 10 milliseconds. Oh. Horrible. So we've got to split that one up. What's the ones after that? 4 milliseconds. Sorry, 6 milliseconds. Okay, so it's like a 12 millisecond one. Wow. Yeah, you know what? I want to add a 9th. Because it's not fast enough. We've got to have the extra frame. It's okay. It's okay. Now let's think about this reflection map. Any thoughts of using Holy See? No. Does Holy See still work? Like, is it maintained by anyone? Okay, so we'll probably have to do the double buffer thing for this guy. And the first one takes 12 milliseconds. The next one takes 6 milliseconds. So that means the one after that probably takes oh no, wait. The next one is the rest of the MIPS. Yeah. So okay. That's interesting. But yeah, so we've probably got to do this is terrible. A reflection image. We've probably got to do this again. So more VRAM, unfortunately. But we could probably more VRAM. This is the way. Now does it have Vulkan bindings? I don't know. I don't know how like similar it is to C, to be honest. I know it's maintained, but it was interesting offshoot. Right. Basically the opposite of Rust. I like it already. To be honest, I did use Rust for like 4 years. I thought Rust was great in terms of like, hey, let's do like a new clean language from scratch kind of thing. But obviously the borrow checker stuff is a bit much. Yeah. Like and any unsafe Rust is like super verbose. Like offset and pointers is done in bytes and stuff like this. And anyway, and lots of casting. It's very wide code when you try and use unsafe Rust. Lots of unnecessary characters everywhere. Not nice. So I want to do a similar thing with this reflection map. The image that we want. Okay. Oh, so the definition of printing made me unreasonably angry. What was the definition of printing? In what, sorry? In Holy See? Or Rust? Okay, so with this one, I'm not sure. Yeah, so I think we need different reflection. Oh, it's so bad. The MIP 0 needs to be launched a few times, that's for sure, I think. And then uh yeah. Rust, you have to overwrite. Oh yeah, the debug template. Oh yeah, that sort of like trait thing. Yeah, true. Define a two-string method, I hate. Give Java a middle. Right. Yeah, some of the trait stuff can be a bit boilerplate, I guess. Yeah. I do like though how it did. You know, I'm not a fan of move semantics and all of that, but the fact that Rust forces them in the compiler, the move semantics as they're part of that copyable trait thing and all that, right? Non-copyable, you know, it's it's great, but it kind of defaults stuff to be not, you know, uh, the structures just not be plain old data by default, which is a bit bad, I think. But if you're a C plus, I think it's better than C plus plus the way it does it though. If you want to do the C plus plus thing, then that's what Rust is, right? It's a better C plus plus. You know, it's like what happens if we could just do C plus plus again? That's what Rust is. It's not a C replacement. Okay, so we're gonna have to do that silly. You know, I think we actually had 1024 on here before, but I reduced it to 256 because it was like stupidly slow. Right, if it takes 12 milliseconds at 256, times that by 4, yeah, it's like 50 odd milliseconds. So that would take so long, but it looks nice. Um, I'm not sure if I could see a difference, to be honest. That's why I did it less. Now, so what do we do here? So we're basically got to try and accumulate some new kind of hmm, you know, reflection color into a buffer divided by some weight. The beautiful thing about the other one is the weight was constant, so we could basically pre-divide it by the weight and sum it into the uh, image. Each frame that we try to do more work. Now, here though, if we were to say split these sample counts into less per frame, say we did 32 per frame, something like that. Or you'd have to divide by 12 actually, so even less. The total weight is is a product of the n dot L. So, you know, realistically, they ain't gonna work. Now we could have another texture that stores the total weight, right? But then you're adding another texture on top of already adding another texture. So that's not ideal. We could also just accumulate it into the buffer. Oh, no, you can't. Yeah. Oh, wait. No. No, you can't. It's horrible. Super horrible. Is there a better way we can parallelize this? Well, the beautiful thing is actually, hang on a minute, is this one is a super big resolution. It's a full screen image, meaning that it could probably benefit from just doing less pixels in general. But then it is going to spend a lot of time anyway because these are very expensive and long compute. You know, look at these. These guys are a whole bunch of maths, right? So, and they've got sampling and all that, right? It's expensive. So ideally, the less of these we did, the better too. But also, hang on a minute. Hang on. N.L is normal. Okay. Yeah, it's the reflection, isn't it? So per pixel, you could kind of know the total weight at the end. You could create a lookup table at some point, but then that's another texture, isn't it? Of the total weight. So at the end, you could just go over all of the weights for the final one. You could go over all of the weights. Yeah, yeah. So for the final one, you could recompute the total weight, and that wouldn't be that expensive. Oh no, it would, because you'll need to pre-compute H again. But that might not be so bad. But then wait a minute. Does anyone see something that I see? There's a spare alpha channel. Isn't that interesting? So we already have an extra value. That's cool. That we're just doing nothing with. Absolutely nothing. This could be great. And we're doing that in the other one as well. The irradiance map. So maybe, man, spare channels. So if you have a spare channel, right, so we could just store the whole thing in the alpha channel. Yes, we could avoid doing the divide. The problem is the 16-bit per pixel render target. That's going to be a bit of a problem. Maybe. Because when you accumulate so much color like that, it's going to you're probably going to bump into floating point precision problems at some point. Put it that way. It would be better with a float 32 target. Yeah. Okay. Right, I think I've got to put a pin in it there today. But so next stream we'll finish off this reflection map thing and get the performance all in the right place for sky rendering. Then we want to make it even slower again by by adding some stars, and we want to also add a nebula, right? Because our nighttime is like super bad. We're not going to do exactly this nebula, but we're going to be inspired by it. It just does a fractal Brownian motion. Is that what you call it? FBM. So we'll probably do a 3D FBM, which will probably be quite slow. But yeah, we'll do this and make nebula or nebulae, whatever you call it, in the night sky with some kind of stars or something like this. These stars look kind of cool though. Maybe we'll just do these stars. But yeah, this will be fun. So sort of the performance problem. We'll finish off the performance problem next time with this. I'll get some more ideas, and then we'll just do make some nice sky, and then we can get back to materials towards the weekend, I think. Awesome. So there's a schedule down below. Oh no, this is in Vulkan. It's all in Vulkan, but it does use GLSL, the shading programming language. And yeah, if you want to follow, there's a Discord channel. If you want to come and chat in the meantime. Yeah, it's like a C-like language. Yeah, exactly. And if you want to support the channel, and oh, that's the complete wrong one. Don't do that one. For crying out loud. That was the old link. If you want to support Hero Studio or Hero Studios, feel free to support via that link. There, there's a membership basically, and you'll be able to get the code and run it on your local machine on Windows only. Windows 11. All the details are on the code file there. But thank you for everyone who's supporting the channel. Appreciate you all. And yeah, I'll hopefully see you all on Thursday, 7:30 p.m. GMT. We'll also do a Friday and a Sunday one as well. Right, have a good rest of your night, and I'll see you all on Thursday. In a bit, guys. Bye.